Hello, IBSL AI students going through your mock exam. You've never had an exam in IBSL AI before, so we're using a sample paper for the mock, and if necessary, we can go to old SL exams or studies exams. Okay, so getting right into it here. We want to be able to use the formula booklet and our knowledge to make progress in this exam. Basically 6 points per question for paper 1. So we want to be able to do this in 6 minutes, this question. All right, so there are the instructions up top. You're usually given on paper 1 answer boxes. Okay, it looks like I missed out maybe, or maybe it's on the next page for the first question. Should be on the next page. There it is. Okay, so we should answer this question in the answer box, and these pages will be facing each other. That's just mechanics. All right, so this is a statistics question, which is topic 4, statistics and probability. Topic 4, and we're going to use the formula booklet to answer some of the questions, and our knowledge from core chapter 12 to answer this question. All right, so you're given a box and whisker diagram here. You can zoom in a little bit. It's a little bit faded. The information that we know on box and whiskers is that we're given the low value here. This would be the first quarter value. The median is in the middle data. The Q3, the third quartile value is there, 240. And the highest value in our data is looks like 290. Okay, so we're supposed to write down the median weight of the puppies. We should just be able to read from the graph right here that it's 210 grams. Okay, and we're going to include units in our answer. All right, the upper quartile we can see is 240 grams from the diagram. And the interquartile range we can get from the formula booklet, Q3 minus Q1. Okay, so we're just going to do a simple subtraction. We don't have Q1. Well, Q1 is 190. Okay, here. So I'm going to do Q3 minus Q1. So the interquartile range is 50 grams. And we're going to box our answers, especially if we have some workings. Do that to make it easier for it to be graded by the examiners. Okay, the weights of these 3 Labrador puppies are normally distributed. We're not really asking questions on normal distribution, but it could have been included here. So now, what is an outlier? So we need to establish what an outlier is, and I have to refer to the textbook for this. Wrong textbook. The outlier is defined by taking the upper quartile, Q3, plus 1.5 times the interquartile range. That's for the upper boundary of what may be outliers. And then the lower boundary, we just subtract that 1.5 times the interquartile range. So back to our calculations here, we're going to take the upper quartile, which is 240, and we're going to add 1.5 times 50. So I think that's 75 without using my calculator. So I think this is the upper boundary for outliers. Okay. And you can see that our top value was 290, so we don't really have any outliers in this case. All right, let's move along to the next question. Here is a question involving sequences and series. So this is topic 1, number and algebra. And the information on it, again, we have some formula in the formula booklet, and it comes from Core Chapter 5. So here you can see we have the answer box right below there to answer the question and show our workings and answers there in the same place. Okay, so the first question is to write down the common difference. I saw a lot of people had a formula for that they memorized. Again, we're just going to take one term and we're going to subtract the term before. I'll just make that u plus 1, and I'm going to subtract u of n. So basically, if I subtract 650 minus that, I'm going to be going the other direction actually for addition. So, but if I subtract, I'm going up. So I just do 650 minus 6,800. And that's going to be the same actually as 6,300 yen minus 6,550. So I think I get a D value of negative 250. And we could put a units on there and make it yen. All right. Calculate the price in the 16th row. We have a nice formula for that in the formula booklet. Topic 1, I said. So this is page 3 in the formula booklet. We have these formulae here for terms in a sequence and the sum of the series, basically, of a sequence, arithmetic sequence. And it does say in the question, arithmetic sequence. Okay, right here, arithmetic sequence. So this is an arithmetic sequence. It wants the price of the 16th row. So we just take the first row from the formula, which is 6,800, and we add 16 minus 1, n minus 1 times negative 250. Okay, so when I do that calculation, the prices are getting cheaper and cheaper. I'm going to get down to 3050 yen for that question. Okay, and then we want to buy 2 tickets in each of the first 16 rows. So they've helped us out a little bit here by letting us know the first and the last term in a sequence. So basically, we're going to be adding up all these terms, U1 through U16, and then we're going to multiply that result by 2. All right, but we have the series formula to help us with that. So I like the second version here of the series formula because it uses the first and last term. The first version is if we don't know the last term in the sequence, we can determine it by using this formula and substituting. Okay, so I'm just going to take n over 2 times the first term plus the last term. N over 2. First term was 6,800. And the last term was 3050. Okay, and when I do that calculation, that's 8 times that sum, and I get, I forgot, I got to multiply that by 2 also, because it's 2 tickets. So I got to take that whole thing and multiply it by 2. Okay, and when I do that, the first sum was 78,800, and when I add multiply that by 2, I get 157,600 yen for 2 tickets in each of the first 16 rows. Question 3 on paper 1. This comes from topic 1, topic 4, statistics and probability. We're going to be looking at some data here. That's group data. First question is whether this is discrete or not. It's a count. It's a number of students. You can see there are no decimals or fractions or anything. It's either 0 or 6 students that use the internet in each class. So we're going to take that number and be multiplying all these to find a mean and divide by the total number of students. Okay, so the first answer that I would write on my answer sheet, which is down below here, again, I would just put A in there and say that it is discrete. All right. Don't think I need a box on that. They'll be able to find that answer. Okay, so the next question is, again, this grouped discrete data idea. If you look in the formula booklet, page 10, it talks about the mean of a set of data is going to be equal to the sum of however many we're going to add up, taking the frequency, multiplying by the value, and then divide by the total number, okay, which is basically adding up all the frequencies here, which is what this says in Greek. Okay, so we're going to add up, like I said, we're going to be multiplying all of these numbers. So 0, I don't need to do that. The numerator is going to be 24, which is 1 times 24, plus 60. Sorry, I'm doing this in my head. Plus 3 times k. We don't know what that is, so we're going to leave it as a variable 3k. And then, lost my screen there. 4 times 10 is 40. 5 times 3 is 15. And 6. And then we're going to divide that whole sum by the denominator there, which is again adding up the frequencies, 20 plus 24 plus 30 plus k one time, 3k when we multiplied it, and then 10, 3, and 1. And then when we finish all that calculation, we should get a mean of 2. That's what x bar is. Okay, so I did a little bit of addition there, added up all the numbers. I got 145 plus 3k divided by 88 plus k is equal to 2. So again, we're going to do some nice algebra here for these 4 points that are going to be awarded. So I bring up the 88 and I get 2 times 88k plus k, sorry. And then 145 plus 3k stays there. Then I can expand and I get 176 plus 2k is equal to that. And then subtract 2k from both sides and 145 from both sides, and I get, that's really terrible writing, sorry, k is equal to 31. Okay. Then the final question is identify the sampling technique used in this survey. Again, you're going to have to, study up on the sampling types and errors that are in Chapter 11. This is in Chapter 11B that has the sampling methods. And this sampling method, because he went, it was not possible to go to every student in the school. The headmaster thought he would just ask every 10th person on a list. So that sounds like systematic to me. Okay, it's systematic sampling. Okay, so I don't know if we want to put a box around that. Question 4. This is a functions question, topic 2, and information on functions and inverse functions can be found in chapter 3 of your AI book. All right, so this is a curve that gives us the perimeter for a given area of a square. Okay, so up here you see the y value, the perimeter, and the input is going to be area of the square. They give you that the area has to be positive, of course. Okay, so this is the domain of the function is basically that a is greater than 0. Okay, so when a is there, the graph of p is shown for 0 to 25. Okay, and that is going to be basically the range of your function. Okay, so input, output, domain goes to range. That's for the function itself. Okay, we're going to switch that around and find an inverse function in a second here. Okay, so first question asks for write down the value of p of 25. So again, the answer sheet is on the next page that we have to answer the questions. So we're going to input 25 for area, and we're going to find out what the perimeter of the square would be. Well, it's if you look at the scale here, it's 2 every tick mark on the x-axis. So 25 is about here. Go on up, come across, and you see that the perimeter is area. So this is a 5 by 5 square. So it's 5 by 5 by 5. That's going to give you a perimeter of 20. Okay, so the function works. Okay, so that's the answer to A. P of 25 is equal to 20. All right, B. The range is from 0 to n of P of A. Hence, write down the value of n. So these are the y values. Basically, you can see that this curve goes up to 20. That is basically what n is going to be. Okay, the area goes to 25. The perimeter goes to 20. And you can just write 20 or n equals 20. Okay. And then C is going to be graphing. On the axes above, draw the graph of the inverse function p minus 1. So we're going to be going backwards, inputting from the y value and getting out an x value. That's what the inverse function is doing. We're going to flip x and y. So I think the best way to do this is look at some points on the graph and start flipping them. I want to be very precise here. Okay, so this is a precise point here, 4, 8. Okay, so that's 4, 8. Pick another one here. This one, 12 comma 14. 12 comma 14. I got to figure out where that is right there. Sorry. And then next point, again, we know that 2520 is a point, 2520. Okay, so flip those points around and start plotting them. So 8 comma 4 is here. Okay, 8 comma 4. 14 comma 12 here. Okay. Up there we had 2520, so I go 20. Sorry, I got to go up a little bit. 20, 25 is right around there. Okay, and sorry for the blob there. How many points were on the question? I think it was like 3 points. So if we plot these 3 points accurately, we can do more. We should be able to come up with the inverse function. And in fact, where is y equal to x? Somewhere right here. Okay, right there is actually 16 comma 16. Again, square 4 by 4. 4 plus 4 plus 4 plus 4 for the perimeter. Yeah, that's it. Okay, so the inverse function looks something like this. Okay, so we're going to get points for hitting those coordinates, and also another fact that we should have learned is that if we reflect the original function on the line y equals x, the identity function, basically, that's y equals x, goes up at a 45 degrees angle. If we flip the function over that, reflected across that, we get the inverse function. Okay, so that is that. As we said, it was 3 points down there. And in the context of the question, what does p minus 1 of 8 mean? So again, we're coming in from the perimeter side of the equation, that the area basically for a perimeter of 8 is 4. Okay, that is what I would write down. That p minus 1 of 8 means the area is 4. Sorry, FOUR, area 4 for perimeter of 8. And again, that's, if you look at it, 2 by 2, 2 by 2 by 2 by 2, add up all those numbers, you get 8, multiply them, you get 4. Question 5, this is another topic 2 question on functions. This one's going to be an exponential question. You have this situation where birds are migrating to a warmer climate during the winter months, I guess. And this is a model given. It's an exponential decay model because you have a negative t here. As time goes on, this amount will become smaller and smaller and smaller. Okay, so first question is find the population of the bulbul birds, okay, at the start of the migration season. We have to interpret that as time equals 0, okay, and then in the wetlands after 5 days, you can check the scale. Yes, it is number of days for the function. So we're going to put in t equals 5. All right, so again, first step might be to put this function in the calculator. I think I already have it in here. Yes. 1350 plus 400 times 1.25 to the negative x. Okay. I delete that for now. All right, so you can look at the table or you can evaluate this function. Anything to the 0 power, that's the initial, is going to be 1. So the answer should be 1350 plus 400 for that first question. Look at the table. 0, 1350 plus 400, 1750. Okay, so that's going to be the answer to A. And then the answer AI, A double I is going to be after 5 days, 1481.1. You can't have 0.1 of a bird, but we're going to round it to 3 significant figures. Make it 1480. So I might do it like this with function notation. P of 0 is equal to 1750. I could show some workings. It is worth 3 points. And then that's I. And then double I is P of 5 is going to be equal to 1480, about. And units are birds, or bulbul birds, if you want to write the whole thing. Just putting units on my answers. All right, so B says count the time taken for the population to go below 1400. So again, we could solve this equation algebraically, not in our course. We'd use logarithms. But we're going to just use the calculator. So we're going to put y1 is already this one, and we're going to put a horizontal line at 1400 for y2 to get the intersection of those two functions. All right. So that's why I had in y2 1400 before, because I'd done this problem before. All right, so there's 1400. I'm just going to go with the standard window for now and show you that you don't see anything in the standard window. Again, we're way up in the y-axis. We're up in the 1750 is the maximum population of birds. We have to be up there. And then the time axis I really don't have a feel for. So what you could do is you could mess with the window and try and adjust it, or you could just do zoom 0 is a zoom fit. All right, so when you hit that, it should show the two curves and even the intersection. It should. Sometimes it's not there, but difficult to see, but there is an intersection down here in the lower right-hand corner. So B, you're just going to find the intersection of those two lines on the TI-84. So we go to the trace button after hitting second, of course, to get to calculate. We hit 5. And then if there's only one intersection, we just have to hit enter 3 times. If there's more than one, we're going to have to get closer to the intersection we're interested in. But there's only one intersection, 1, 2, 3. And I get 9.32 days. Again, the birds are moving all the time. So yeah, the decimal place does actually apply. So I'm just going to say that T is approximately equal to 9.32 days. And it didn't ask us to do it in minutes, hours, minutes, and seconds or whatever. I guess it could have, but that would make it more complicated. Okay, and according to this model, find the smallest population of bulbul birds during the migration season. Okay, so we can see that the bulbul birds are decreasing here constantly. Maybe even if we zoom out, I have to hit enter after I hit zoom out. I might see a better picture. Yeah, it's really zoomed out. But you can see the blue line is kind of leveling out there. It does go through the red line, but it looks pretty level just below 1400. Again, I can do it a number of different ways. I could trace. Sorry, I didn't mean to hit that button. What if I just hit trace and just go right? Yeah, see it's going down to a number. I'm really leaning on the trace button. And look, it's getting to 1350. So that is going to be the minimal population of the birds. I can see that in the table also, or I could substitute a very large number for T. Of course, we're talking migration season, so I'm not going to do more than 30 for T probably, but you can see it gets down to 1350. That's the minimum population. 1,350 birds. Horizontal asymptote. You get a point, I guess, if you say that, because it's only 1 point. Question 6. This is a study. You have a tally chart here, basically a frequency chart, a tally chart that was turned into a frequency chart. And what this tells us is person's position in the university, students, professors, staff, and administration. That's one variable. And the other variable is how frequently they ate salad. So this is statistics and probability, hypothesis testing. We want to see if these two variables are related, dependent, or independent, because we're going to do the chi-squared test for independence at a 5% level of significance. Okay, so we can go to the calculator here and put in this data. But first, let's answer the question, what is the null hypothesis? Basically, the null hypothesis is that the two variables are not related. And for the exam, they would like to see the word independent. Okay, so which is the dependent variable, independent variable? It doesn't really matter for the score, but I think the number of salads is independent, how frequently, or frequency of salad eating, how frequently they eat salad is independent of position in the university. Okay. Is. All right. That's my null hypothesis. And again, I could abbreviate that as H naught. Okay. That is the standard symbology for the null hypothesis. Okay, so we're going to calculate a p-value for this test. Calculate. So we're going to put this data into our calculator and do a chi-squared test for independence, because that's what this question is on. All right, so calculator, this stuff goes into a matrix. I'd like to be able to see the data. So go second, matrix. This is going to be our input matrix, edit. And this is three rows and 4 columns. It looks like I've already put the data in. Okay, great. Okay, so once I have all that data in, all I have to do is, I like to quit, come back out and do a stat test. This is a test for independence. And unfortunately, I don't see it here on the screen, so I got to go up or down until I get to the chi-squared test, not the goodness of fit test. This is the test for independence. Okay, and I hit that, enter. My observed matrix, I put in a 3x4 matrix, 3 rows, 4 columns. The expected matrix is going to be written in B, which is, again, you're familiar with how to calculate that manually, row frequency times column frequency total divided by the total, okay? And then calculate. Okay, so when we calculate it, we get a chi-squared value, which basically is talking about how much our observed frequencies are differing from the expected frequencies. Looks like a lot. And then this is the probability that the distribution is due to randomness. So I think this is a pretty low probability. This is our degrees of freedom. Rows -1 times columns -1, which would 3x4 would give us 2x3, 6. So this is actually the value that they're asking for, the p-value for the test. And it says 2 points, so I don't know what we put for the input to get the second point. But again, you did the TI-84 and you put it in a matrix, and you did the chi-squared test. Okay, and that gave us a P of approximately 3 significant figures now. 0.0201. Okay, that's my answer to B, to 3 significant figures. And then C, state for a reason whether the null hypothesis should be accepted. I said before, it looked like there was a significant difference from the expected frequencies. The null hypothesis is rejected, actually. Reject null hypothesis because you could say 0.02, etc., is less than 0.05. So this is your p-value. This is your significance level. Okay. Question 7 on topic 3, Voronoi diagrams, the last chapter in the book. All right. This is going to be on the exam. I mean, it's a new topic. Never had it before in studies or SL. So be ready to do it. You're given a diagram that shows where these snow shelters are in the national forest. Okay, just in case there's a blizzard and you got to hang out somewhere warm and dry. Okay. Calculate the gradient of AE. This is just basically the gradient formula that we had in functions, where you just take the coordinates of the points and find the difference there to find M. So AE, we need the coordinates for A, 3, 1, and the coordinates for E, 7, 3. Three, 1, 7, 3. Okay, so M is going to be equal to, for question A, the difference in Y's over the difference in X's. So that's 2 over 4, 1/2. Okay, that is the gradient of AE. Okay, so here they've started the Voronoi diagram, basically constructed by using perpendicular bisectors. We have to complete cell E. So we should see that they have these lines starting to close in a polygon on site E, and we're missing something over here. It looks like to close up the polygon because it's open in this direction. So what we're actually going to be doing is a perpendicular bisector between A and E. The other perpendicular bisectors have been constructed already. So this could be done with a ruler and compasses quite easily, but we're going to do it algebraically. And we're going to give our answer in the required form, ax plus by equals d, etc. And d is, they're all integers. Okay, that's what that says. All right, so we need to find the midpoint. Again, the midpoint formula is in our formula booklet. We have some more complicated ones here for 3 dimensions. But you know, in the beginning, prior knowledge, they have the midpoint formula here. Okay, so we're just going to add the x's, divide by 2, to add the y's, divide by 2, and you have the midpoint. Okay, so B, you're going to add the x's, divide by 2, add the y's, divide by 2, and those are the coordinates of the midpoint. Maybe we should call that MP or M, not M because we just used M. So that's going to be 3 plus 7 divided by 2, 5. 3 plus 1 is 4 divided by 2, 2. Okay, so that's the midpoint. And then we want the perpendicular gradient because this is a perpendicular bisector. Okay, so we're going to use the negative reciprocal of 1 over 2. So you're basically turning that upside down, or you're using a formula similar to this. Turn it upside down and multiplying it by -1. So the perpendicular gradient M2 is equal to -2. Okay, so these are the information that we're going to use for our line that's bisecting the points A and E. Back to the formula booklet. My preferred method for doing this is to use the point gradient form. I like this formula, and then we can rearrange it into the required formula. Okay, so and we can use either point. Sorry, it's the midpoint. So I do y minus y1, which is 2, and then I take my gradient and I do x minus the midpoint, 5. Okay, so this equation needs to be rearranged. Expand the brackets. Make sure negative times a negative is a positive. Add 2x to both sides. Subtract 10 from both sides, and I get 2x plus y, subtract 10, 12 equals 0. So that's the answer to B. Okay. Sorry, I ran out of room here. In the context of the question, explain the significance of the Voronoi cell containing site E. 1 point. Again, the sites are closer to any point within that cell than any other site. Okay, so we have to be able to say that concisely for the test. Site E is closer to every point in cell E, or something like that would be using the correct terms. site E is closest to all points in cell E, or in that cell. Okay.